everyone. Welcome to the DI 101 webinar series. This series is an incredible resource offered to our customers, partners, and associates of Distribution International. By partnering with our manufacturers and our industry experts, these webinars deliver informative presentations about industry trends, new technology, new products, and product applications. I'm Jared Evans. I oversee the marketing function for Distribution International. And I want to welcome our presenters today. We're extremely excited to partner with Owens Corning FOAMGLAS for today's webinar. Today's topic from our guests will discuss performance of an insulation system in a critical application relies on more than the choice of the insulation material itself. The design of the system, the functionality of each of its components, including adhesives, sealants, vapor stopping materials, vapor barrier jacking, and proper installation must all be carefully considered. In this webinar, we will review the importance of proper accessory selection in common cold and cryogenic service applications and discuss features, functionality, and attributes of high-performing accessory materials. Let me introduce our presenter. We have several panelists from Owens Corning FOAMGLAS. Our primary presenter, though, is Colin Smith. He is a project manager for Owens Corning FOAMGLAS and their industrial accessories portfolio. He has been in the role for 2 years, during which time he has overseen product testing, development, commercialization of new accessories, and has been an active member of the National Insulation Association's Young Professional Advisory Committee. Prior to joining Owens Corning, Colin worked in the food manufacturing industry and is a proud graduate of the University of Minnesota. And I'm going to butcher this pronunciation, but so Colin, help me out. The University of Barcelona.
Yeah, the Universitat Autònoma de Barcelona.
Perfect. Yep. That's way better. I grew up in Deep East Texas. I would not have done that well. We are proud to have Colin and Owens Corning FOAMGLAS present today. Certainly thank them for their time. We will pause for questions at the end of the webinar. You can submit questions at any time throughout the webinar. Just there's a questions tab on the GoToWebinar control panel, and you can submit your questions. Just type it in and submit it at any point during the webinar, and we will answer the questions during that question period at the end. Without further delay, I will turn this over to Colin Smith with Owens Corning FOAMGLAS. Colin?
All right, thank you very much. And thanks for everyone for attending today. And again, a big thanks to DI for giving us the opportunity to host this webinar for you all. So as Jared said, my name is Colin Smith. I'm a product manager with our team, managing the industrial line of our FOAMGLAS accessory products. And the topic today for high performing accessories, we believe is an important topic because, as Jared had highlighted, the performance of an insulation system in critical applications, as contrary to however some people may think, is a lot more than just the choice of insulation material. Jared highlighted a number of those factors like the system design, functionality of the components, and the proper installation. All of those really make up, along with the insulation material, the system, which are critical in order to be able to for the system to work as it's designed to. So before we begin, I wanted to provide a little bit of background on Owens Corning as a company. So most of you may know Owens Corning as it relates to the insulation industry, but we're also a global leader in engineered materials for roofing and composites as well. All three of our businesses, we strive to create solutions that'll help save energy and improve comfort in both industrial and commercial applications. So we're based in Toledo, Ohio, and while we're global in scope, I think as many companies and probably many of you around the world are experiencing right now, it's really the people who make a company what it is, and Owens Corning is very proud of its people. Within the insulation business at Owens Corning, we have operations around the world which really allow us to leverage our global capabilities and deliver innovative solutions to our customers. We strive to deliver quality insulation products and systems to serve within a variety of applications. and the materials that are used in those variety of applications as well. And to give a little bit of perspective on the size of the business, the 2019 revenue for the insulation business within Owens Corning was 2.7 billion, which is roughly about a third of Owens Corning's total revenue. So looking at the insulation business globally, we have about 7,400 employees in 20 countries around the world. Speaking of the FOAMGLAS, cellular glass insulation business specifically, we have production facilities in North America, 2 in North America, 2 in Europe, and 1 in Asia. But we have sales representatives all over the world working in many more countries than these listed. So within North America, we also have a broad network of channel partners that act as both fabricators and distributors. So companies like DI, who are an integral part of our business and how we go to market. Now, for those of you who may be a little unfamiliar with FOAMGLAS cellular glass insulation, it's a lightweight, rigid material with a closed cell structure. So that closed cell structure actually makes it impermeable to water and water vapor. And it's also non-absorbent and offers high compressive strength. So along with these other benefits, it also has a wide service temperature range from cryogenic to above ambient, which you can see here on the slide, and which allows it to be used in a variety of applications from LNG to tanks, fire suppression, underground as well. As I mentioned before, the performance is a lot more than just the insulation itself. So which is why we utilize and follow a systems approach and offer a compatible portfolio of accessory products, which we'll talk about in a little later. So going into more detail about this approach and kind of how we view a system, they're comprised and consist of the system design, which includes the type of material that is used, the accessories that are within the system, assembly instructions and installation, along with supplemental technical support like product testing and product training as well. So the FOAMGLAS team manages a library of over 125 system specifications covering the temperature range of the FOAMGLAS material. So these specifications, they detail the appropriate materials that should be used within the application. They talk about the proper assembly instructions, and they include several detailed drawings to further illustrate the system setup. Our global portfolio of accessories consists of over 30 products, which suit the needs for the specifications that we manage. So highlighting the portfolio itself, we have a broad range of products, which include sealants, jackets, vapor stops, coatings, adhesives, and fabrics, along with accessories for tank-based applications and others as well. But in this webinar, we'll focus just on a few of those categories and detail the importance that they serve in cold and cryogenic insulation systems. So to give you an idea of kind of what we view as a system, here's an example of all of the various components that would go into, say, a cryogenic pipe insulation system, where each product serves an important function. So in the next few slides, we'll discuss each of these products, their importance, and then the functional benefits that go along with them. So first, we'll talk about sealants, which are important to the system because a continuous seal along the full length of the joints is essential for the system to perform as desired. If the seal fails, then the failure point can allow for vapor drive into the system and reduce the effectiveness, which obviously has further damaging issues that might go along with it. Because the FOAMGLAS insulation is impermeable, really the only permeable part of the system is the joints. And so therefore, it's critical to choose a high-performing accessory because these joints can become the weak point in the system if the sealant doesn't perform and function properly. Now, within our systems and the specifications that we manage, the primary sealant that's used in industrial cold and cryogenic applications is PitSeal 444NS. It's a specially formulated butyl sealant that's used, as I said, to seal the joints in the system. It's offered in 5-gallon pails, as well as 10.3 fluid ounce count cartridges, depending on the usage and preference. Now, this product has several features and benefits as when used in these types of applications. The first of which being that it's non-curing, which means that there's no cracking in the material or separation of the joints as a result of the material drying out. Now, this also helps the material to work across a wide temperature range while maintaining its ability to react to joint movement. The product itself also is not stringy, which can be a drawback when working with some other potential butyl sealants. And as some contractors and some other channel partners may be familiar with, the FOAMGLAS business used to offer a previous version of this sealant, which was stringy when working with and made it difficult, especially on the contractor side for in-field applications. So this version, the 444NS, was modified to create a cleaner application and make it more contractor friendly. Now, finally, on this product, not only is it compatible with FOAMGLAS and its other accessory products, but it's also compatible with a wide variety of other insulation substrates, as well as stainless steel. So it's used in a lot of different applications, but it's most commonly used in below ambient and cryogenic applications, as listed there. So as I mentioned, an important aspect of the installation system is the technical support and the assembly instructions that go along with it. So to help with that, the FOAMGLAS technical team has worked on creating detailed drawings depicting how the system components are used and how they should be installed. So throughout this webinar, we'll highlight some of these different drawings and kind of show you how these various systems and the accessories work within them. So in this drawing, particularly of a single layer cold pipe where the PitSeal 444NS is often used, you can see that the joint sealant is applied to the full depth of all of the joints. And in certain applications like this, the PitSeal 444NS also serves as a vapor stop. Another example for the sealants of a drawing is when you get down to colder temperatures, a double layer of FOAMGLAS insulation is required. So this is because as joint sealants get cold, they don't function as well. So the double layer of the insulation really keeps the interleaving space between the two layers of FOAMGLAS at the temperature so that the joint sealant is at its optimal functionality. In this example of the cryogenic pipe, the joint sealant is applied just like before, full depth, but this time it's only applied to the joints of the outermost layer. So the benefit of using a non-curing joint sealant in these types of applications is really highlighted in some of these images here. So both of these materials were held in an oven for a period of time and then evaluated their physical properties after. And a non-curing material, like on the left, won't dry out and it'll maintain its stickiness, which you can see in the thumbprint on the right side of that image. Other materials, they'll dry out and they'll crack, which then can offer a weak point for moisture to enter into the system, which, as we talked about with FOAMGLAS insulation, that being impermeable, really that it would be the only impermeable or the only permeable point of the system. So it's important to keep those joint sealants flexible and able to keep those joints closed. So another property of these types of sealants that we like to evaluate is the tear of the material. So the nature of the tear correlates pretty well to how stringy a product is when you're working with it. And like we had talked about before with our previous version, that can cause some messes when you're working with it in the field. So ideally, we like to see a tear of a couple inches or less, like the image on the left. So moving on to vapor stops and fabrics. So the most susceptible point of a system for moisture to enter are protrusion, supports, and terminations, which is where and why vapor stops are important, because they help prevent the potential for moisture to enter the system at these points. While a fabric is important to provide structural reinforcement of the vapor stop and other coatings that it's used with. In our specifications, pit stop 196 is a common vapor stop that's used in these cryogenic applications. It's a two-component butyl rubber elastomer, which has been formulated specifically for use at these lower temperatures. And because foam glass is impermeable, we recommend that a two-part vapor stop be used, because otherwise there's potential for the material to not cure properly. So as I mentioned, the primary benefit of this pit stop 196 is its ability to perform at these cryogenic temperatures, but it's also resistant to industrial chemicals and has a very high solids content as well. So as for where it's specified, as we mentioned, ideal for use in applications like liquid natural gas or other cryogenic applications. So commonly used with pit stop 196 is PC Fabric 79, which is an open mesh synthetic material for reinforcing vapor stops and coatings, and it has a number of functional benefits as well, first of which, the large mesh of the fabric allows for the easy penetration of the coating and vapor stop, while the knitted weave of the material is actually designed so that it doesn't unravel. The fabric is also very flexible, which is important given that, as you'll see in the next slide, the vapor stops are typically stair-stepped down the insulation, so flexible fabric is able to provide a better 90-degree angle down those steps. Also, the thickness of the material provides the required strength, but it also serves as a gauge for the proper coating thickness. So in this drawing, we're looking at a double layer termination at a cryogenic temperature, which you can see up here in the protrusion above, as well as the termination to the left, particularly to the left, where the stair stepping of how the vapor stop and the fabric is stair stepped down the different layers of the insulation. So you can see how important having a flexible fabric is, so that you can really get those 90-degree angles. In terms of the installation of these products, the vapor stop should extend onto the bare pipe, which helps to ensure that all potential entry points for moisture are sealed up through the insulation and under the jacket. As you can also see, and as we talked about, it's recommended that the joint sealant PitSeal 444 NS be applied behind the insulation layers, extending at least 2 inches behind the vapor stop. This is because oftentimes a vapor stop is installed later in the process, so applying the joint sealant first can help keep moisture out of the system until there's time to go back and apply the vapor stop. Moving on to the next component in a cold and cryogenic insulation system, which is the jacket. These serve two important functions in these types of applications. So not only do they serve as a vapor barrier to keep moisture from entering the system, but they also provide important mechanical protection. So without a proper jacket on the system, on the insulation, the system can be susceptible not only to moisture getting in, but also to physical damage. One of the most popular products that's spec'd within these applications in our portfolio is PitWrap B100. It's a self-sealing jacket consisting of high-tech butyl adhesive with a 3-layer film. It's available in a couple different size rolls and depending on the needs, as well as butt strips. So it has several functional benefits within these applications, the first of which is the butyl formulation, which was really optimized to flow into the foam glass insulation cells, the top layer of those, allowing for superior adhesion to the substrate of cellular glass, but it also works really well with other insulation substrates as well. Because of the nature of this butyl product, It does have some self-healing capabilities as well. And then for any damage, any significant damage beyond self-healing capabilities, the product allows for repairs to easily be made in the field. Also, when used in combination with the PitSeal 444NS as the joint sealant, the butyls from each of the products actually fuse together in order to provide an even stronger bond against moisture getting in. The film that's used on top of this is, it offers a high level of protection against puncture and tear, as well as provides temporary UV resistance, which means that you can install the jacket over the insulation and then come back up to 6 months later to clad it. So it offers a greater flexibility in trying to schedule some of those activities on the job site. The product is typically spec'd on LNG and cryogenic applications for freeze thaw protection, but it's used in a wide variety of other applications as well. So moving on to another jacket that's in our portfolio, which is the PitWrap IW50AL. So this is a 50 mil thick self-sealing modified bituminous membrane with a 3-layer aluminum foil film. The high-tech bitumen allows for excellent lap adhesion and substrate adhesion, while the foil, similar to B100, actually provides the same high level of protection against puncture and tear, and offers the same temporary UV resistance as well. The product also offers increased flexibility over a previous 50 mil product, which makes it easier to work with and easier to cut and install. Like B100, this is typically spec'd for freeze thaw protection, but its ideal usage is with asphalt roller coated foam glass insulation, as the bitumen from the jacket and from the coating fuse together to form a superior adhesion. Finally, we do have a third product that's commonly used in these applications as well too, a 30 mil product that where thinner material is preferenced. Being bitumen based, it has very similar characteristics to the IW50AL, but without the temporary UV protection. So finally, as safety and ergonomic concerns are an important consideration for both usage in both the shops and in the field, we're rolling out a new design of the box for these 3 previously mentioned jackets to try to make it a little easier to maneuver and work with. So it features handholds for easy handling, a perforated seam along the long edge for easier access to the roll, as well as a built-in suspension rack, which allows you to unroll the product while it's still in the box and be able to cut it. So this box right now is currently on the PitWrap IW50AL, and it will be rolling out to the IW30 and the B100 in the next coming months. So going back to the previous drawing of the single layer cold pipe system, now you can really see how the jacket is applied over the insulation with the laps and some of the details, such as the laps should be offset 2 inches for best performance, and that the jacket needs to be installed in a watershed position, which just further helps to keep the flow of moisture off of the jacket. So this drawing depicts the PitWrap IW50AL, but other jackets like B100 can be used as well. So another common application or a common component of these systems are coatings, which are important because they serve as a protective vapor retarder over the system. So the product that we have in our specifications is the PitCoat 300E, which is a moisture curing coating which cures to form an elastomeric layer, and it's commonly used with our PC Fabric 79, which we previously talked about. It's available in multiple sizes, different grades like spray or trowel, to try to suit the particular needs of the application. In many of the different applications that this is used, only one coat might be required for optimal coverage, which can help potentially reduce installation labor time and costs. which I know everyone is trying to look for. But also because this product is commonly used over irregular surfaces like elbows and tees, its high elongation really serves as a functional benefit for it to be able to move over and cover those irregular surfaces. Also, it has a high solids content of between 95 to 98%, depending on the grade. And as I mentioned, typically used in these cold and cryogenic applications, but it can be used in underground as well. So an example of a drawing where the Pitco 300E is used in a cold application, you can see in the protrusion above that the Pitco 300E provides a vapor barrier over the irregular surface, like that protrusion, and it extends onto the pipe and under the jacket. So in this drawing, you can also see that the Pit Seal 444NS is used to seal the joints and provide a vapor stop along the length of the pipe, while the B100 is installed over top of the insulation for added protection, as we talked about. Finally, the last category that we're going to talk about in our accessory portfolio are adhesives, which are important in the system, not only because they allow for materials to bond quickly to each other, but also because the flexible bond that they create upon curing allows for also helps to absorb mechanical and thermal shock that the systems experience. So two of our common adhesives in our portfolio that are used in these applications are PC88 and PC99-2K. And similar to our comment on the vapor stop, with having a two component adhesives are preferable as well for use between two layers of impermeable foam glass insulation so that they can cure properly. The first product on the left, PC88, is a two-part polymeric adhesive. It's used to bond foam glass to not only itself, but also other substrates as well. It has excellent wetting characteristics, which allows for quick adhesion. And when cured, it forms a flexible bond, as I mentioned, to help absorb some of the shock that systems go through. It has a wide temperature range, so apart from cold and cryogenic applications, it's also commonly used in fire protection applications, as well as containment areas to adhere foam glass insulation to concrete. The other adhesive in our portfolio that's typically used is PC99-2K, which is a two-part moisture curing polyether adhesive. It's particularly well suited for use for vertical and overhead applications because it provides an instant hold. And also this product does not contain any isocyanates, so it's ideal for systems in places where those are not able to be used. So talking about an example and a drawing showing a common application for the PC88, here you can see in a column bottom, the adhesive is used to adhere the foam glass insulation directly to the bottom of the column. You can also see here that in green, the Pit Stop 196 is being used along with the PC Fabric 79 as the vapor stop, while Pit Seal 444NS is serving as the joint sealant once you get to the piping. And finally, we do have a cryogenic adhesive as well that can be used for applications outside of PC88's temperature range. So to touch just briefly on compatibility, we really look at this in two different ways. The first is compatibility with foam glass insulation and other foam glass products. And the second is compatibility with other insulation materials. So regarding the foam glass, obviously because they form a part of our system, all of the accessory products have been tested specifically for use with the cellular glass insulation, and most in systems as well too, with other accessories that are commonly used. Also with our accessories, most of them have been formulated specifically to optimize the usage for cellular glass so that we know that they perform at the optimal performance with this type of substrate. As for compatibility with other insulating materials, Many of our accessories are chemically compatible, and they have been used in the past on projects with, say, XPS and polyiso. But for more specific questions pertaining to compatibility with these other insulation materials, please feel free to contact our FOAMGLAS technical team. So we went through a lot today, and I wanted to thank everyone for their time, and especially to DI. We appreciate them giving us the opportunity to share this information with you. I hope this information was helpful to be able to provide a valuable look at the cold and cryogenic systems and the importance that these accessories play within those applications. So with that, I will open it up to questions with our panel of FOAMGLAS experts, including Bill Rose, Bobby Farrell, and Alan Dickey. Thanks again.
Thanks, Colin. Appreciate that. We do have several questions that have been submitted. So as we kind of work through these, just want to remind everybody that if you think of a question now late, just use that questions tab there on the GoToWebinar panel and submit it, and we'll get to it. So the first question I have, what is the compressive strength of the standard block that is fabricated into pipe insulation?
Alan, you want to take that one?
Sure. Yeah, the average compressive strength would be 90 psi of the flat material, and we actually recommend a design load for pipe supports on the pipe insulation of about 20 psi, and this is because the geometry is not necessarily, consistent, and we take that into account once you fabricate it into pipe insulation.
Great. Next question. What is the standard length of fabricated FOAMGLAS pipe insulation sections?
I'll take that one. We offer the insulation in 2 foot and 3 foot lengths.
All righty. Next question. Can pit stop 196 be used on other insulations as a vapor stop? Will it work on FOAMULAR? What are the limitations?
Alan?
Yes, I think we've evaluated that product for use on a number of different products, and I guess the only limitations would be it is a 2-component product. You'd have to make sure you have the equipment to mix it. The other side of the coin is that it is for outdoor use. You wouldn't want to necessarily use it indoors because of the solvents that are involved in the product.
Great. Next question. Will the use of B100 eliminate the possibility of galvanic corrosion of aluminum jacket?
Alan, you want to take that? Maybe you can relate to the test we just finished with TSA coatings and whatnot.
Sure, there should be no galvanic element to that once you put the jacket in there, because it's going to act as a conductivity vapor barrier. The other thing is the B100 jacket, although it has this aluminum foil in between, that actually the surface of that foil has a polymer coating. It's like a film, polymer film, so it's non-conductive in that that direction.
Great. What is the vapor permeance value of pit wrap B100 and pit wrap IW50 aluminum jacket?
Alan?
I'm gonna have to look that up. They're basically 0 perm.
You're right. Yeah.
Okay. Can I-30, is it I-30 or 130, be buried?
IW30. No, we do not recommend that it be buried.
Okay. Last one. I have 2 more. what are the 3 components of the PC42?
Alan?
All right, PC42. All right, so we've got essentially there's an aggregate or a sand component. You've got a reactant, and then the base adhesive, which is I believe somewhat like an epoxy, but I don't know the exact chemical nature of it.
Okay. And last was, do you offer any on-site training for contractors? And I can kind of answer this on the DI side, and just that that the DI has partnered with manufacturers to do some things like that when requested by the contractor. And I'm sure, you know, if that request were to come, that DI and FOAMGLAS could figure out a way to provide that kind of insight and training. But I'd certainly want the FOAMGLAS guys to chime in on that.
That's probably a soft toss for Bobby.
Yeah. Hey guys, great job, Colin, and thanks everybody for joining us today. Yes, we offer on-site training. We offer trainings in our training center locally here in Fresno, and our 2 other locations, one in China and one in Belgium. We can do trainings not only for the contractors, but for the fabricator distributors, the engineer owners. We like to get a group together sometimes on some of these projects where you have the contractor doing the installation. You have the engineer design group along with the inspectors, all reviewing the specification, going over the application, so that saves a lot of time out in the field and confusion. So we offer this.
Great, thanks, Bobby. And I've been to one of Bobby's trainings at the Fresno facility, and it is certainly informative and a nice facility. It's a great training facility. I think that's all the questions we have. Let me just take one more look. Oh, I take that back. We have one more. Can or should Pit Seal 444NS be used on FOAMULAR?
Alan?
Yes, yeah, we evaluated that product with FOAMULAR and a number of other things, including PIR and other products. So yeah, it can be used with other installations.
Great. That's all the questions we have. Again, thanks to the Owens Corning FOAMGLAS panel. Thanks to Colin. Very informative information today. And just want to wish everybody the best as we all kind of work together as an industry and as a society during this pandemic crisis. So I know it's hard times for everybody, but I just want everybody to know that all of our customers and associates and manufacturing partners, that DI is here with you and working with you as we get through this. So we'll get through it all together. Thanks, everybody. Enjoy the rest of your week.
All right. Thanks, Jared, for hosting.
Thank you. Thanks, Jared.
Thank you.
Thank you.